We can solve first order differential equations of this form using separation of variables. So we call this a separable differential equation because we can divide through by gy on both sides and multiply through by dx. So therefore we've separated the variables x and y, and then we can thereby integrate both sides of the equation and then solve this equation to obtain y as a function of x. And note that when we evaluate these indefinite integrals, we're going to get some constant of integration. So therefore y of x is going to depend on the value of that constant, and that constant can have an infinite number of values. So therefore we call y of x a general solution to this separable ordinary differential equation, or a family of solutions. And we'll apply this technique in the coming example. Let's find the general solution to the following differential equation. So what we're going to do is put it in a form where we can separate the variables. So dy dx is equal to sec squared x multiplied by y. And now we can separate the variables. So we have dy on y is equal to sec squared x dx. And now we can integrate both sides. So on the left hand side we get the natural log of y, and on the right we get tan x plus a constant of integration. And now we can take e to the power of both sides. So therefore we obtain y is equal to e to the power of tan x by e to some constant, and this is just another constant. So we can write y is equal to some other constant by e to the tan x. And that's our general solution, which you can differentiate and substitute back into this equation to verify that it satisfies the original differential equation.